This video introduces a LoRa test solution provided by RedwoodComm. It demonstrates how to test LoRa devices using RWC5020A LoRaWAN tester and its PC application software. At first, let's take a look at the tester for standalone use without PC application. This is the sample device to be used for this demo. Push menu button to choose the operating mode of the tester. The first is end device test, the second is gateway test, and the last is non-signaling test. Select the end device test first. In end device test, the tester operates as a gateway including network server. It has 4 submenus: link analyzer, power versus time, power channel, and receiver sensitivity. Link analyzer helps us make connection between the tester and the DUT using LoRaWAN protocol. Push param button to open the parameter screen and configure protocol parameters. Select region. We support most of regions defined in LoRaWAN protocol, only except of 700 MHz. Protocol version. User can select version of LoRaWAN protocol that DUT supports. Also, we support all classes from class A to C. Select activation method. In case of OTAA, application key, device EUI, application EUI must be configured before testing. These DUT have already been configured to do OTAA procedure after power on. Application key and both EUI values were configured as 1. In case of ABP, device address, network session key, and application session key must be configured before testing. Let's use OTAA for this demo. It is recommended to enable set test mode parameter if DUT supports certification test mode. Upon receiving the first uplink message after activation, the tester will transmit activate test mode command to the DUT. Select downlink slot. It's selectable as RX1 or RX2 for class A. In case of class B, ping slot is another option for downlink slot. You can also configure parameters of join accept message to be used in OTAA. Jump to RF tab. Configure TX power of the tester. Its range is from -10 to -150 dBm. Determine it depending on the test purpose. Configure channel mask, and the channel information will be shown as below. After finishing configuration, close the parameter screen and push Run button to start tester operation as a gateway, including network server. Now the tester is waiting join request from the DUT. Let's turn on DUT. The tester received the join request and replied with join accept. The tester issued activate test mode command to enable the test mode of the DUT. In test mode, the DUT repeats sending downlink counter periodically. In link analyzer screen, various protocol parameters or messages can be analyzed, such as spreading factor, bandwidth, measured power, F count, and so on. In addition, at the cursor position of a message, its contents are shown at the bottom, and its raw data is also displayed in hexadecimal format. Now, let's take a look at the advanced feature of link analyzer. That is transmission of MAC commands. Push param button, jump to link tab. This is the list of all MAC commands defined in LoRaWAN protocol. Select one of them, for example, device status request. Close the screen. Push MAC send button at the bottom of the screen. Then the command will be sent at the next downlink slot, and you will see how the DUT will process the command. RWC5020A allows transmission of multiple MAC commands in a single frame as well. Push again param button and change the number of commands to 2. Let's select link area request for the first. And RX param setup request for the second, and close the screen and push MAC send, and you will see how the DUT will process multiple MAC commands. Yes. Now let's switch to power versus time. It measures the TX power of DUT continuously whenever it receives a packet from the DUT. The power measurement data versus spreading factor will be just displayed as a table at the bottom. DUT is using SF12 now. Let's try to change it to SF9. Go to link analyzer. Push param button. And set ADR DR to 3. Close and MAC send. Now DUT is using SF9. And it can be shown in power versus time as well. In power versus channel, the power measurement data versus physical RF channels will be displayed as table. The channels can be modified by sending link ADR request command as well. The last submenu is receiver sensitivity. Here the tester measures packet error rate to find the minimum sensitivity level at which DUT can receive packets from the tester properly, in order to guarantee the PR result will not exceed the limit. Push param button to configure test parameters. We provide two test scenarios for receiver sensitivity test. One is normal uplink and the other is 30 echo. In normal uplink scenario, whenever DUT sends uplink message, the tester sends downlink message of confirmed type. To measure PR, the tester checks acknowledgement flag in the next uplink message of the DUT. In 30 echo scenario, The tester issues activate test mode command to force DUT to enter the test mode. And the tester uses echo commands to measure PER. 30 echo is preferred if DUT supports certification test mode. In this demo, let's set packet number to 10 and start power -132 dBm and step power 1 dB and target PER 10% and downlink slot RX1. Also set target SF to be tested. Jump to RF tab and set path loss to 0.7 dB to reflect this cable loss. Close the screen and push Run button. Okay, test finished. If PER exceeds 50%, the test will stop automatically and show the final result of sensitivity level and PER value. Of course, sensitivity test in signaling mode takes a long time because LoRa communication is very slow. Nevertheless, it must be meaningful since it is the test result of normal operation mode. We also provide fast PER test method applicable to manufacturing lines. Refer to another video clip or application notes from our website. That's all about how to test an end device in standalone operation of RWC5020A. Push menu button and switch to gateway test mode. It also shows the same submenus as end device test. In gateway test, the tester operates as an end device and the gateway must be connected to its network server for signaling test. The test concept is quite similar to end device test, so let me skip a demo for gateway. Push menu button and switch to non-signaling test. It has three menus: signal generator for RX test of DUT, signal analyzer for TX test of DUT, and MFG for combined manufacturing test in special mode. For MFG test, refer to another video clip or application notes from our website. In signal generator, any type of LoRa test packet can be generated and transmitted as users want. Push param button to configure parameters of packet. In NST TX tab, basic parameters for packet transmission can be configured. In Protocol tab, DUT type or more detailed parameters for PHY back layer can be configured. In RF tab, frequency and TX power and path loss can be set for receiver sensitivity test. Let's assume DUT is in RX test mode. Push Run button. The tester will transmit the test packet. Then the DUT counts how many packets it receives by itself. In signal analyzer, the tester receives the test packets from DUT and measure TX power. To do that, test parameters can configure as similar to signal generator. Push param button and switch the tab. You can set all parameters. Push run button. Tester will wait for test packet from DUT. Now switch DUT to TX test mode to transmit test packet. But demo is skipped in this video. Thanks for watching the video. If you need more information, please visit our website or send email to sales@redwoodcomm.com.